Hello coders! In this video we are looking at a straightforward approach to day 9 of Advent of Code 2022. This puzzle is approachable by anyone who has learned the basics of coding. More specifically, this guide uses lists, sets, loops, and custom data types like classes or structs. That's it! Nothing too fancy. I've posted a link to the puzzle in the description below this video, and if you get stuck, don't hesitate to post your questions in the comments or make a post on the Advent of Code subreddit. Tons of people there always willing to help you out. And of course, if this guide helps you, let me know, click that like button, and if you want to see more of these guides, be sure to subscribe. Let's get into it. The expedition continues to make its way toward the Starfruit Grove when it encounters a rope bridge spanning a gorge that was carved by a massive river far below. The bridge creaks as you walk along it. You aren't sure how old it is or if it can even support your weight. As you step carefully across the bridge, its ropes stretch and twist. To better determine where you should step on the bridge, you decide to model the physics of the rope. Can you write a program that will simulate the rope's physics? Welcome back, Captain Coder here with day 9 of the Advent of Code 2022. As you just heard, we are attempting to cross a dangerous bridge and need to better understand the support rope physics. As always, when approaching these puzzles, it is important to understand what it is asking you to model, as well as what the final result should be. In this puzzle, we are modeling two actors, sort of a head and a tail of rope in a two-dimensional grid, so we're keeping track of their positions. The first actor's the head here, so if we look down at this example, we have an H for our head and a T for our tail. The head is an actor that moves in an orthogonal direction, north, south, east, west, left, right, up, and down, and the tail responds to how the head moves. If the head moves in a space that is either the same space as the tail or a space that's adjacent, either orthogonally or diagonally, it stays in that position. It doesn't move. If, however, the head moves into a space that is not adjacent to the tail, there are two things it can do. If the head moves orthogonally away, the tail just follows orthogonally next to it. So in this example, if the head moves to the right, the tail follows it, just moving next to it and staying orthogonally adjacent. If the head, however, moves diagonally away from it, so for example, if it was in the position to the top right of the tail and it moves up, it is now diagonally away from it. The tail also moves diagonally so that it will remain orthogonal after the move. This happens in each direction, and so the tail can move into one of 8 spaces depending on where the head has moved. The puzzle gives us some examples for our input, and the inputs are the instructions for the moves, how the head is going to move, and our goal is to model where the tail follows behind it. We get a starting position. Both the head and tail start in the bottom left corner of this example, which happens to be 0, 0, though we can move into positive or negative ranges. And at the very, very end, we are asked to tell how many positions the tail of the rope visits at least once. So we're going to keep a set of all of the positions that the tail visits, including the start position. And finally, we report the number of unique positions that it visited. So with a better understanding of the puzzle, let's talk about a strategy for solving this. First, we're going to define some new types for us. We're going to define a position type to model our positions, an X and Y position, and a move instruction, which is going to model how a position can be updated on the grid. Second, we're going to write a function called follow such that we can determine where our tail should move given a position of our head. Third, we're going to write a function to parse our input into a list of our moves. And finally, if we have all of these things, we can simply iterate over our list of moves, moving our head, checking where our tail should follow, updating our tail, and each time we do this, we keep track of the position, we add it to our set. Once we're done iterating through all the moves, we simply report how many positions are contained in our set. With our 4-step plan in place, let's go ahead and hop on in. For this puzzle, I'm going to define 2 new data types. The first one is going to represent a single move in our instruction set. So for example, we can move right, up, left, or down. So I've defined a data type here. It's called a move, which represents an offset of a direction we're going to move. And then I've defined 4 constants defining our directions. So right would increase x by 1, left would decrease x by 1, up would increase y by 1, and down would decrease y by 1. Then the second model I'm going to use is a position type, which has an x and y, and we're going to write a function here, move, which is going to take in a position and a move, and it's going to return the new position where we should go. For example, if we pass in right on a position, that position needs to move to the right one. If we pass in a left, the position will need to move to the left one. And so it's going to return a new position that contains that new spot. In this case, I've gone ahead and I've written a test here. We can test it out. It's gonna fail on us because we have not yet written an implementation. But the idea is I've gone through and I've defined if I have a position at 0, 0, and I move to the right, the new position, the thing that I expect it to be, should be 1, 0. If I move up from that position, so I'm at position 1, 0, that's the result. If I move up, I end at position 1, 1. If I move left, I end up at position 0, 1. If I move down, I end up at position 0, 0. So if this test passed, I have some confidence that I have a move function that's going to accurately tell me where my position moves given a move instruction. So go ahead and give it a shot. See if you can write yourself a test, write an implementation, and try to pass your test. I hope at this point you have a working move function, that your test move is passing, and that you're happy with your solution. I'm going to show you mine. Pretty straightforward. I simply take the X and Y positions of the position that were passed in, and I increase them by the X and Y in my move, and then I construct a new position and return it. Notice I'm using immutable objects in this. This means that my objects cannot change. If you're using a mutable object, that's okay too. The next step is to create a follow function here. I've defined it in the following way. I'm going to take in a head position and a tail position, and it's going to return the position that the tail should move into if it is following the head. I am also going to write an isAdjacent helper method here. This is just a method that takes in 2 positions and it tells me true if they are adjacent to each other and false if they are not adjacent to each other. In our program, diagonally adjacent counts, so you want it to be if it's orthogonal or diagonal, returning true. And you probably guessed it, I'm gonna write myself some tests to give myself confidence that my follow is working. You may not have written tests on past parts. I really recommend writing some tests for this one because the logic isn't super simple. In this case, there are 9 different positions our tail can end up in. First ones are the ones where the tail does not follow. So anytime the head moves into a position that is either adjacent or directly on top of the tail, it shouldn't move. So I've written a test here that shows all of those possible outcomes. We have an easy one when we move to the east, when we move north, south, and west. So if our head is orthogonally away from our tail, we should move in that direction. Then there's some tricky ones. Northeast, so how do we follow when the head is north of us and east of us? How should we move when it's north and west, south and east, and south and west? So I really recommend writing these tests for yourself. then implementing your follow method, and then testing it, running through, seeing if it works. And when you get all greens on these, you have a lot of confidence that your follow function is going to work for the big input. Hopefully you have a slew of green check marks informing you that all of your tests are passing. That is the case for me. If you're not quite ready, go ahead and pause, but I'm about to show my solution. So here it is. My follow method accepts a head and a tail position. It starts off by checking if the head or tail are adjacent. If they are, I just return the tail. The tail doesn't need to move, so I just return that position. Otherwise, I go ahead and find the amount of X and Y difference I need to do. In this case, I take my head's X position and my tail's X position, and I translate that to either a 1 if I need to move to the right, a 0 if I don't need to move in the X direction at all, and a -1 if I need to move to the left. Same thing for my Y. I subtract my head Y value from my tail Y value, and then I normalize that to a positive or -1 or 0. And then I simply return a new position, adding in that offset to the tail's X and the tail's Y. So that's the overall solution. Let's take a look at the trickier bits. Let's look at is adjacent. So for is adjacent, I know I'm adjacent if my X and my Y distance are at most 1. So I find the absolute value of the distance from my X and Y between the two positions. And then I check that they are both less than or equal to 1. And then this find sign method is just a little helper I wrote to determine, given a number, if it's 0, I simply return 0. If it's positive, I return 1. And if it's negative, I return -1. And the last function we need to write is a parse function that's going to take in an array of inputs, which are going to be our inputs of R4, U4, L3, etc. And it's going to produce for us a list of moves that we're going to perform. So for example, we would end up with 4 move rights, 4 move ups, 3 move lefts, 1 move down. And as usual, I've written a test here and I have moved test. I've given an example here, which is the first 4 lines of my input, R4, L2, U3, D2. And I call parse on this example, and I expect it to be the following list: 4 move rights, 2 move lefts, 3 move ups, and 2 move downs. Currently, if I run this test, it fails because I haven't done an implementation. So go ahead, write yourself a test, see if you can implement it such that your test passed, and good luck. And I'm happy because my parse test is passing. It's giving me confidence that it is working and will work for bigger inputs. If you're not quite here yet, go ahead and pause before I show my solution. So here's my solution. I take in an array of strings. I initialize a list of moves. I iterate through each row of my input. My input's gonna have 2 tokens, a left side and a right side. I split that and I find the number of times I'm gonna need to make this instruction by parsing the right token, the second token, into an integer. I create a loop that loops that many times, and each time I create a move by looking at the left token here. So I have R goes to right, L goes to left, U goes to up, and D goes to down. Finally, once I have that, I just add it to my list. So I loop through every row, create the appropriate number of moves, and add those to my list. Finally, once I'm done iterating, I simply return that list. With all of our functions in place to solve this puzzle, we're ready to go. I am going to read in the input, turn it into an array of strings, pass it to my parse method, get back a list of moves, initialize my head and tail position such that they start at 0, 0. I'm going to create an empty set that I'm going to add my positions to. I start by adding my tail to that set. Then I iterate through each one of my moves, moving my head, checking to see if the tail should follow, and then adding the tail's position to my set. Once I'm done iterating through that whole list of moves, I simply print out the size of my set. Go ahead, give it a shot. If all went well, you have a program that's displaying a solution. Given the example text here, my program says the tail visited 13 unique positions. And if we look at our example solution, that is correct, giving me confidence that when I download my input, I will get a correct solution. So I'm about to show you my solution. If you haven't quite got there yet, go ahead and pause. And here it is. I read in my example.txt into an array of strings. I parse out a list of moves. I initialize my head and tail to be at position 0. I create an empty set to store all of my positions. I add tail to that set because you have to make sure you get the first position in there. Then I start moving. For each move, I update my head's position using my move function. Then I update my tail's position using the follow function. Finally, I go ahead and add the tail to my positions. Because it's a set, I know that this set will not add duplicates. That's the definition of a set. A set cannot have duplicates, so be sure you're not using a list. And then finally, I write out that the tail has visited the number of positions that are inside of my set. All that's left is to download that puzzle input, pass it in, cross your fingers, and if you're lucky, you'll get that beautiful gold star. Hopefully at this point you've submitted your solution and received a beautiful gold star. I hope you found this video helpful. If you did, let me know. Click that like button. If you want to see more Advent of Code guides, click subscribe so you'll be notified when they're uploaded. And as always, have a beautiful day. Keep on coding, keep on growing, and you're welcome back anytime.